View. Now, there's not a lot of math going on in this unit, right? It's mostly just knowing vocabulary stuff, right? Concepts, knowing properties. It's a lot of memorization. We won't get into next unit. We get into more like solving equations, and it's much more mathematical, much more algebra involved. Hadn't been much in this unit. Let's review. This is a little bit, I guess, right here, right? Converting from words into math. That's probably somewhat mathematical. We had a little bit of like order of operations stuff, so not a ton. But let's take an opportunity and review some of this stuff here. So how would we say the difference of 5 and a number? It's telling us to use x to represent the number. What do you think?
5 minus x.
5 minus x. There you go. Good. So 5 minus x. Now that's different than the difference between a number and 5. How would I say that? X minus 5. And they mean different things, right? For subtraction and division, the order is important. For multiplication and division, or multiplication and addition, we can interchange things and it doesn't affect the outcome. Okay, how about something like this? How would I say if I'm using x as the variable, how could I say the quotient of 12 and the difference of 4 in a number? Think about that one for a second. Okay, your goal today is, everybody's goal is to answer one question. I'm not going to call on people today yet. I'll start calling on people soon, but yes, sir.
12 over 4 minus x.
There you go. Okay, good. So we know the quotient of 12 and, so 12 divided by something, what? Divided by the difference of 4 in a number. Well, that looks like 4 minus x, doesn't it? Okay, give me thumbs on that. Does that make sense? Okay, all right. Okay, now this time we're just matching up a bunch of descriptions of sets with the sets, the blue answers down here. Let's start at the bottom on this one. How about the very bottom one? How would we say that, first of all? What do you think? How do we say that? It's using that weird set builder notation. The set of all, set of all A over B, such that, okay, good. So the set of all A over B such that A and B are integers and B is not equal to 0. Well, what set of numbers does that describe? Rational numbers, right? Because rational numbers are the numbers that can be written as fractions, okay? How come B can't equal 0? What's going on there? Because you can't divide by 0. Exactly. So we have to include that little thing, don't we? Yeah. Okay, so this is the set of rational numbers. Okay, let's go up to the top here. How about that top one? What's that? Integers, good. Okay. And how do you know? Well, you just have to memorize it. What's the best way to memorize facts like this? These are like state capitals. It's just memorizing facts. But what's a good study device for that? Flashcards. I've got an unlimited supply of index cards. If you want index cards to make flashcards, help yourself. Or you can build them in your book, right? If you go to the textbook and you go down to I can't remember, I showed it to you, right? When you go into your textbook, it's kind of down on that list of things you can do in your textbook. You can build these virtual flashcards, and it saves them for you, okay? How about the next one? Yeah, how about that? The set of all x such that x is a real number and x is not a rational number. Well, if it's real but it's not rational, then it must be irrational, sure. Okay, so that goes there. How about the next set? Natural numbers, because they start at 1 and they go forever to the right, don't they? Yeah, so that's natural numbers. The set of all x such that x is rational or x is irrational. That's real numbers, isn't it? Yeah. Okay. How about the next one?
Well, due to processes of elimination.
Okay, but say you weren't looking at the process of elimination here. Why is that the set of whole numbers? Because you're counting up from 0 by 1. Yep, that's the whole numbers, right? Okay. Okay, how about this one? This is a little different. This time we want to build a set that corresponds to that what's given to us there, right? So this is given to us in set builder notation. We want to write a set in roster form where we're just including all the elements with commas. What would that be? The set of all x such that x is a whole number less than 8. Let's get somebody different here. Be brave. Somebody be brave here. What's that going to look like? What pieces or what elements does that set include? Okay, 1 through 7, and there's one other one we need? 0, perfect. Okay, so we'll go 0, 1, 2, 3, 4, 5, 6, 7. Okay? Give me thumbs so far. We good? Okay, all right. Okay, this one, people had trouble with this, but I think initially, I think it was just because they didn't understand how to do the question. So let's make sure everybody understands what's being asked here. So we want to know for each of those, what is that, 6 numbers, one at a time, we want to know what sets include that number. So starting off, we're looking just at the number 0. So that's A. So what can you tell me about that? What sets does 0 not belong to? Okay, irrational and natural. Everybody see that? It's not irrational. It's not natural. But it is real, isn't it? It is a whole number because the whole numbers start at 0. It is rational, right? Because we know that real numbers and whole numbers have to be rational. Those are subsets of rational. And 0 over 1, we could write it as a fraction. And it is an integer. Okay, it is a hash mark on a number line. So, yeah. How about 34? Think about it. Everyone take a second and think about that one. Which would we choose? There's going to be a lot of them probably, right? Might be easier to say which one do we not choose. It's everything else though, isn't it? Right? It goes all the way down to the natural numbers. Okay, how about -9/8? Think about that one. Everybody take a second, contemplate, think it over. That one's not in quite so many, is it? Let's think about just the sets that do include that number. Somebody give me one set that is included. Real numbers, they're all real numbers, aren't they? So real numbers are going to work. What else? Rational. Anything else? That's it, right? Good. Okay, how about square root of 49? Now that looks tricky. It looks like a radical, so everybody's probably thinking irrational, but we could simplify it, couldn't we? We could rewrite that as 7. Okay, and once we rewrite it as 7, then that's going to include a lot of stuff. What's the only thing that doesn't include? Irrationals. Yeah, it's just like 34, isn't it? Okay, now how about that one? Okay, this is a little different. Can we get rid of the radical by simplifying this time?
No.
And if we're stuck with a radical, what is it? Irrational. Yep. And it's, of course, it's also real. Yeah. And then finally, and we got a decimal here, so we got to be careful on this one. What is significant about that decimal? What about that decimal tells us what kind of number it is? Okay, it doesn't repeat. Does it go forever? So what's it do? Terminates. Good. So if it's a terminating or a repeating decimal, what kind of number is that? Rational. If it's a random one that doesn't repeat and doesn't terminate, just goes forever randomly like pi or any square root, then that would be irrational. But this one is rational, and then it must be real also, right? But that's it, right? It's not, because it's got decimal places, it can't be any of the other stuff. Okay? Give me thumbs. Okay? All right, I know we're going fast. Okay, this is really simple, but it's still, sometimes people have trouble with this. If you're not sure how to simplify, I would highly recommend, on the test especially, on your paper, write down PEMDAS, right? So what am I doing? Is there any parentheses here? Nope. Any exponents? No. Any multiplication and division? Yes. What do I do first? Got to go, good, I got to go left to right. Multiplication and division are equal from left to right. First thing I see is negative 12 divided by 4, which is negative 3. Then I multiply by 3 and I get, there you go, bingo. Okay, this is the most commonly missed question that I saw, believe it or not. This is the one I got the most questions on, seemed to cause the most issues for people. I bet it doesn't anymore, but it did at the time at least. Let's talk about this one. So first of all, there's a couple steps here. What's the evaluate part? Okay, plug the numbers in, right? That's the plug part. Okay, so we're going to plug in 8 goes there and there, and negative 2 goes there and there, right? So what's that give us then if I plug that stuff in? On the top, I've got 4 plus 3 times the absolute value of 8 minus, what happens if I subtract negative 2? Okay, that becomes adding, doesn't it? So I get 8 minus negative makes it a plus 2 over 8 plus 3. Now, how am I going to write that negative 2? Okay, could I write it like, could I write it like, come on, oh, this thing's going to break. I know it is. Could I write it like that?
No.
Okay, that's horrible, right? Because that looks like I'm subtracting the 2 and I'm not. I'm multiplying by the negative 2, so it needs to be in parentheses. Okay, so now we've got a division bar. We can separate the top from the bottom. What's going on the top of this thing? What do I have to do first? Okay, good. I've got to work. Do you see any parentheses here? Absolute values count as parentheses, right? Anything that groups counts as parentheses. So yeah, I've got to do everything inside first. So I get, what is 8 plus 2? 10. Okay, so that becomes a 10. What's the absolute value of 10? We can evaluate that too. That's just 10, right? So on the top then we get 4 plus 3. And then if I'm multiplying by 10, I could either put a dot there or I could do this. I could just put it in parentheses. Take your pick. Doesn't matter, right? That's what's on top. Give me thumbs on the top. Does that all make sense? Okay, on the bottom, what do I do first? Okay, 3 times negative 2. So that's going to give me 8. And then 3 times negative 2 is negative 6. So I'm going to subtract 6. Bottom's easy then, right? Okay, so next step. On the bottom, we just get 2, right? On the top, what do I do first? I got to multiply before I add. And this is what, when people made a mistake on this, typically, this is what a lot of people did. They wanted to add the 4 plus the 3 first and get 7 times 10, which is 70, but that's not correct, is it? We have to, if we're going to follow PEMDAS, we have to multiply that stuff first, right? We multiply before we add. So we get 4 plus 30. And we end up then, if we just combine all the like terms on the top, we just get 34 over 2, which does simplify. What is that? 17. Okay, good. Does that make sense? Okay, all right. Okay, let's practice some properties. This is just property stuff. I get why this stuff, this is different. It's not, you haven't done this stuff before so much probably. So it's a little newer. I can see why it might take a little while to get to know what these things all are. Again, it's just memorizing though, right? How about this first one? We got to figure out what property is being represented there. What did I do to the numbers? I just changed positions. So which property is that changes positions? Commutative. You're commuting from home to work, work to home, right? To commute means to exchange places. So that's just commutative. Excellent. Okay, what about this one now? Think about this. I've got how many things being multiplied there? 3. And what have I done to move from the left side to the right side? What did I do? Okay, I regrouped them, didn't I? This is a grouping issue. I changed the numbers that we grouped together first. In this first case, we grouped the 9 times 6, get an answer, multiply by 5. In the second case, we grouped the 6 times 5, so we multiply that first and then times 9. What's the property that has to do with grouping? Associative, because to associate means to group. Who do you associate with? You group yourself or associate with your friends or your teammates, right? Things like that. Okay, so associate means group. This is the associative property. Okay, give me, real quick, I just got to know, give me thumbs on these first two. They make sense? Those are easy to confuse, very commonly confused. Okay, what about this one? Now let me ask you a question. What number did I start with? What number did I end with? So did the identity change? No. So what property is that? Identity property. That's the whole point of the identity property, is we're going to keep the identity the same. We do that by adding 0 or multiplying by 1. Perfect. Okay. Okay, now this one's a little different. This time I didn't end up with what I started with, but what did I end up with? 1. Okay, what's special about 1? What is 1? What's, I don't care if you use all the fancy words, but what is important about 1? It's a whole number, sure, but what about 1 is significant with multiplication? Okay, if I multiply 1 by something, it stays the same. It preserves the identity, right? The I properties go together, identity and inverse. So this is one, the giveaway on this one is that I multiplied 2 things and they multiply to, excuse me, multiply to 1, right? So if I multiply 2 things and the product equals 1, that means I've multiplied inverses, reciprocals in this case, right? For multiplication, inverses are just reciprocals, okay? So which property is this? Inverse property. There you go. Okay, how about this one? I started with a 9. Did I end with a 9? No, so it's not identity, right? Because the identity changed. It went from 9 to 0. Okay, but what's significant about 0? 0 is an important number for addition. I think we already said it. Okay, if you add 0 to something, the identity stays the same, right? So if you add 2 numbers and you get 0, that means you must have added inverses. For addition, the inverses are just opposites, right? So we added opposites. Which property is this going to be? If I end up getting my identity number when I add things, then it must be inverse, right? I added inverses. That's the inverse property. You see the connection there? Okay, it was different than when I added 0. That's identity property because I started with the same thing I ended with. If I get 0 as my result, it means I added opposites, and so it's the identity property. Again, those are easy to confuse. Okay. All right. Now this one is tricky. This top one. How come? Because you see parentheses, right? You see parentheses and you think associative. Okay, but it's actually not. Did I change the things that were grouped? No. So it's not associative. Which one is it? I just swapped them, didn't I? Look at this. Let's color code these. So I'm going to call -8 is going to be my blue term. The quantity 7 plus 10 is going to be my red term. Well, it's equal. So blue plus red is equal to red plus blue. Now it's pretty obvious. What property is that? Commutative. I just exchanged the pieces, didn't I? Okay. Give me thumbs on that one. Does that make sense? Why that's not associative? Okay. That's a tricky one. Okay, Okay, don't overthink that one. What's that one? Yeah, I just distribute the 7, don't I? Okay. Top one. Don't let the fractions confuse you. What's the pattern there? I heard it. It's commutative, isn't it? Look, if that's the blue factor that's being multiplied and negative 11 is my red factor, blue times red equals red times blue. Well, that's commutative, isn't it? I exchange the things being multiplied. Okay, we already did one like that. What gives that away is what it's equal to. If I multiply things and it equals 1, what is it? Inverse. There you go. Perfect. And then going with that, how about that one? Identity. I start with the same thing I end with, don't I? Right? So that's identity. Okay? All right. Okay, real quick. The additive inverse is opposite. What's the opposite of negative 3/4? Positive 3/4. The multiplicative inverse is reciprocal. What's the reciprocal of negative 3/4? Negative 4/3. Just flip the fraction. Okay. Okay, so now I think this is really good practice. This will kind of seal the deal for you if you're confused at all. Use the commutative property to rewrite that. Yeah, commutative means I'm just changing places, right? So we would just exchange the positions of the things that are being added, b plus 3a. Okay. Okay, use the commutative property of multiplication. Excuse me. A times b would equal b times a. Okay, associative property. Got to regroup then, right? Instead of grouping 3 times x, what would I probably group? 3 times 3. 3 times 3 times x, right? And how about down here, associative property for addition? Instead of grouping a plus 3.2, I'm going to group 3.2 plus b. Okay. Thumbs? All right. Okay, we're getting there. Write this sentence using mathematical symbols. Twice the difference of x and 3 is negative 26. Well, let's start with the easy part. What's the is negative 26? Equals. Okay. Equals negative 26. Now, how would I say this? We got to be careful. Twice, what am I doing twice of? I'm doubling what? Okay, that whole thing, right? The difference of x and 3. Okay, but I'm not squaring it. I'm just, twice means I'm multiplying by 2, right? Okay. So how would I say that then? How do I say 2 times that stuff? Can I write it like this? Could I just say 2 times x minus 3? Like that? Give me thumbs. Does that make sense? Ooh, I'm seeing some thumbs down. How come? I need parentheses because I'm doubling that whole blue thing, right? Not just the x. So I would have to have everything in parentheses there like that. Okay? Make sense? Okay. 2 numbers have a sum of 142. If one number is x, represent the other number as an algebraic expression in x, meaning just using x's. How would I write the other number? If the first one is x, what's the next one going to be? Okay, these are a little tricky. Here's a great way to do this. Think about this. What makes this tough is that variable, right? You're not used to dealing with variables like that yet. Pick a value. Pick a convenient value that we're just going to let x be, right? Instead of saying one number is x, let's say one number is, how about 42? If one number is 42, what's the other one? 100. How'd you get that? Okay, but like, what did your brain actually do there to come up with the number 42? You just did 142 minus 42, didn't you? Right? So you just did 142 minus, whoops, gotta get my color straight here, minus 42. Okay, now let's flip back from a specific value to a variable. What value did we choose for x? 42, right? So say, okay, well, let's not be specific. Change that back to an x. What do I get? Yeah, 142 minus x. Do you see the thinking there? Sometimes if you pick a simple specific value like a number, you can establish the pattern, and then all you have to do is say, okay, well, now what if that were x instead of the number I picked, right? The good news is we're going to do a lot of this stuff. I don't know if that's good news to you, but you're going to get a lot better at this. The more of this you do, just the more natural and easy it becomes. It's like anything. The more you do it, the easier it becomes, right? Okay, so last one. Simplify the expression. What do we have to do to simplify this expression? I got to combine like terms, but I'm going to follow PEMDAS. To simplify, I'm just doing that. Okay, what about parentheses? We see parentheses, right? Is there anything in parentheses I could simplify? Okay, no, there's not. I know what you're thinking. You're thinking distribute the -4, but the parentheses part is saying inside the parentheses, so that's everything in there. Inside the parentheses, can I simplify anything? I actually can't, can I? Because inside the parentheses, I have two terms being added that are not like terms. So I can skip that one. Any exponents? No exponents. Any multiplication, because that would be next. What's the multiplication? Good. Okay, that's distribution is multiplication, isn't it? Good. So we'll distribute the -4. There's our multiplication step. And that's going to give us what? -4yz minus 12 minus 8yz plus 1 plus y squared. Okay, well now, what's the last, what do I have to do now to simplify? Combine like terms, which is just adding and subtracting, right? Good. So this stuff is last. If I combine like terms, let's see, do you see any like terms there? Oh, okay, yeah, those two are like terms, aren't they? Okay, any other like terms? -12 and 1. And then the y squared is just a lone wolf. It's out by itself. Doesn't have any like terms, right? So if we combine all that stuff, -4yz minus 8 of those yz's is how many of those yz's? -12. -12 plus 1 is what? -11. And then finally, I've got my plus y squared. And that's it. Okay, good? Okay, that was quick. I just wanted to take one last opportunity to kind of touch base on this stuff with you, though, before the test. So you got the rest of the period. How many people are done with the review? Anybody done with the review? Okay, a few people. If you're not done, you're cranking away on the review. Okay, getting that all taken care of. Make sense? Okay, get questions answered. Go.